day-to-day life. Depending on the type of mixture, we use different methods to separate the components of the mixture. In the lower classes, you have studied how to separate the components of a mixture by using filtration, sedimentation, decantation, and evaporation. Let us now look at other methods of separating the components of a mixture. A separating funnel is used in laboratories to separate two or more. Let's use a separating funnel to separate a mixture of oil and water. Pour the mixture of oil and water in a separating funnel. Note that water being denser forms the lower layer and oil being lighter forms the upper layer. Now, open the tap at the bottom of the separating funnel to let the water run out. Empty the upper layer in a separate container. The principle used for separation of immiscible liquids is also used in the extraction of iron from its ore. The process of separating a pure solid in the form of its crystals from a solution is known as crystallization. Let us see how to obtain pure copper sulfate from impure copper sulfate. Take the impure copper sulfate and dissolve it in minimum amount of water. Filter the impurities from the solution. Evaporate the water in a china dish to get a saturated solution. Cover the solution in the dish and allow it to cool slowly for a day. Crystals of pure copper sulfate are left behind in the china dish. Crystallization is used in the purification of salt and alum. Certain substances change directly from the solid state to the gaseous state on heating. Such substances are called sublimable substances. A sublimable volatile component is separated from a non-sublimable impurity by the process of sublimation. Let us see how to obtain iodine from a mixture of iodine and salt. Take the mixture of iodine and salt in a china dish. Place an inverted funnel over the china dish. Close the open end of the funnel with a cotton plug. Heat the mixture until iodine sublimes and the violet vapors condense around the cooler parts of the funnel. Salt is left behind in the china dish. The process of sublimation is applied in frost-free freezers. Dye sublimation, alchemy, and purification of compounds. Centrifugation is a process in which a suspension is rotated in a circle around a central axis at different speeds. In a centrifuge, the components settle down due to the centrifugal force. Here is a beaker containing a mixture of chalk powder and water. Transfer a part of the mixture into a centrifugation tube. Switch on the centrifuge to allow the tubes to spin for a few minutes. Switch off the centrifuge and look for the sediment at the bottom of the tube. The largest and heaviest materials sediment at the bottom of the tube. The solution at the top, also called the supernatant, can be poured out without disturbing the sediment. Centrifugation is used in microbiology labs and chemical and food industries. The principle of centrifugation is also used to squeeze out water from the clothes in a washing machine. Chromatography is the method of separating and identifying various components in a mixture where the solutes dissolve in the same solvent. Let's see a chromatographic separation. Take a colored candy in a beaker. Dissolve it in a solvent like water. Draw a thin line across the bottom of the chromatography paper, approximately 3 centimeters above the lower edge. Mark 4 crosses on the line, about 1 centimeter apart. Put a spot of the candy solution on the first cross using a glass rod. Then, add spots of known dyes on the remaining crosses to help in comparison. Now, dip the chromatography paper into a solvent. The solvent will carry the dyes present in the candy solution as well as the known dyes upwards in the chromatography paper. The level to which the dyes are carried in the chromatography paper will depend on the solubility of the dye in the solvent. The components of the mixture can then be identified by comparing them with the known dyes. Chromatography is used in fingerprinting and testing for the presence of medicines in urine and blood samples. You have just seen some of the methods used for separation of mixtures. We come across several mixtures in our day-to-day life. Depending on the type of mixture, we use different methods to separate the components of the mixture. In the lower classes, you have studied how to separate the components of a mixture by using filtration, sedimentation, decantation, and evaporation. Let us now look at other methods of separating the components of a mixture. Let's see how to separate the components from a mixture of pentane and toluene. Pentane has a boiling point of 36 degrees centigrade and toluene has a boiling point of 111 degrees centigrade. Distillation is the method of choice for separating miscible liquids having a difference of at least 25 degrees in their boiling points. Heat the mixture in a round bottom flask. Pentane with a lower boiling point vaporizes first and passes through the water condenser. The vapors of pentane are cooled by the circulating cold water in the condenser. The condensed distillate is collected in a collection or condensation flask. Toluene is left behind as the residue in the round bottom flask. Thus, pentane and toluene are separated from the mixture. Distillation is used for commercial production of distilled water, gasoline, alcohol, paraffin, etc. The process of separating the components of a mixture containing two miscible liquids having a difference of less than 25 degrees centigrade in their boiling points is known as fractional distillation. Let's see how to separate the components of a mixture of ethanol and water by using fractional distillation. The boiling point of ethanol is 78.4 degrees centigrade and the boiling point of water is 100 degrees centigrade. The difference between their boiling points is less than 25 degrees centigrade. Heat the mixture slowly in a round bottom flask. The temperature of the mixture begins to rise till it reaches the boiling point of ethanol. The vapors of ethanol are condensed in the fractionating column and collected in a container. When all the ethanol has boiled off, the temperature starts rising again till it reaches 100 degrees centigrade. At this stage, the second component, that is water vapor, rises in the fractionating column. The vapors are condensed and collected in another container. Fractional distillation is used in the production of alcohol.